presented in memory. All right, so how are variables stored in memory? Number one, we need to understand how numbers are represented. And we know that, and if you don't know, then in programming, there's the concept of on or off, right? So this is off, and this is on, or false, true. Okay, and then maybe you've heard the term binary number, right? So we have 1, 2, 3, 4, 5, 6, 7, 6, 7, 8. Okay. Actually, that's not true. That's 1, right? So I start with 1 here. 1, 2, 4, 8, 16, 32, 64, 128. So the way we play this game, for example, the number 10, the value 10 as we know it, right? The value 10 as we know it. How can we represent this number here? Okay, so that's the first question. Second question, or actually the first question should be, what is this, right? So this is 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 bits, and 8 bits equal to 1 byte. Okay. Now we can ask the question, how can this number here be represented over here? So then we play that game where we're like, oh, we use these numbers here, and if we need each one of these numbers to like sum the value 10, right? Then we go ahead and put a 1. If we don't need the number, then we put a 0 in here. For example, here like 1. And then we kind of have to do like for tell the future a little bit, right? Okay, how do I make 10 here? Well, maybe the value 2 and the value 8. Okay, so that means, do I need 1? No. Do I need 2? Yes. Do I need 4? No, because if I do 2 plus 4 plus 8, then I'm going to get more than 10, right? So no, I don't need it. And then I'm like, okay, so I already have 2, right? So do I need the value 8? Yes. Equal 10. So that means I don't need this one, or 32, or 64, or 128. So 00001010 is the representation of the number 10 in binary number with it using 8 bits or 1 byte. Okay. Questions here? Okay, so no questions so far. Okay, so how does this fit into the stack? How does a byte fit into the stack? Okay, so good question. So we're like, well, let's draw a small stack here, okay? And let's assume that in our main, so assume we have our main program, and we have this, and we have this, and we have return 0, which right now we're not concerned about return 0, okay? but we have num int num equals value 10. So how would this be mapped onto the stack? So from the previous lecture, we know for sure that main has to be loaded onto the stack. So then main gets a block of memory where all its parameters and variables that exist in that function will be loaded onto. Okay, here like we're only worried about this guy, int num equals 10. So then we're like, okay, so let's make some blocks here. Okay, so we will assume that this is 1 byte and this is 1 byte and this is 1 byte and this is 1 byte. Okay, making 4 bytes. And your question should be, well, why do we need 4 bytes if this is 1 byte for the number 10? Well, we need 4 bytes because integers, right? Integers or whole numbers in C++ are stored in 4 bytes of memory. We've already figured out 1 byte here. So what would the other bytes be? Right? So we know we need these numbers here, 1, 2, 4, 4, 8, 16, 32, 64, 28. From here we just need 8 and 2 to make the value 10. So 4 bytes. Why? Because the integer in C++ can hold a value up to 2.1 something, right? 2.1 billion something. I don't know the exact number, right? But 2.1 billion something. So 4 bytes would be 4 times 8, so 32 bits, right? So I think if you do 2 to the 32nd power, then you get like 2.1 billion or something like that, some large value, and that's the largest number that you can hold using the data type integer. If you needed a larger number than that, then you would need to use a different data type, but for this class, an integer is fine. Okay, so then let me change this color, and we're like, okay, so how would we map 10, right? So we know we have 1 byte, so we can start here, right? So it will be 0, 0, 0, 0, 1, 0, 1, 0. So we know that's value 10. Keep this in mind, like this large value, right? So then the other byte would have to be 0, right? Because we know what 10 is, 1, 0, 1, 0. So then that 0, and that 0, 0, 0, all zeros, because we do not need those values. So the question would be like, so then that means this would be 256 and 512 and blah blah. Yeah, so it would be doubling all the way up until I think it's to the 31st power, if I remember correctly, to the 31st power. Then you get like 2.1 billion something. That's the highest value that you can get, meaning if all of these zeros here, all of these zeros here were 1, then you would get the largest value that the integer data type in C++ can hold. And that long-winded explanation to help us understand why we need 4 bytes to represent an integer data type in C++. Okay, so it's important to understand. That way, when you get to like a lower level class, assembly language, computer organization, where they're explaining this stuff, then you can make an easier transition from code to memory to like the low level stuff that they're going to be teaching you. Okay, if you just have a general idea, you don't have to be experts at it. This is as far as we go, like in this class. Like I just want to make sure students understand how data is stored on the stack. However, in this class, since we're not dealing with assembly language, when we use the stack with numbers, we will stick to the convention that, okay, main's loaded, so this is main, and main has one number, num equals 10. So then we would just say 10, okay? Assuming this would be like some large memory address 100, then the next block would be x96. And now when you see me do x96, then that means, oh, okay, he's doing a jump of 4, because in memory, the 10 needs to be mapped into 4 1-byte addresses, which equals to 4 total bytes, okay? But this is a convention we'll use here in class, but I want you to understand why we're going to be jumping by 4s, right? The decimal number, which in C++ is a double, we're not going to mess around with that one in one of these blocks because it's too big. It uses 8 bytes. And it makes sense because you need a lot of bits to represent the decimal portion. So that's why it needs a lot more memory to be stored on the stack, right? So questions here?